Welcome to part 7 of our biological basis of behavior. What we're going to be looking at today is brain hemisphere organization, a tiny little bit of consciousness, and neuroplasticity. All right, we will cover consciousness a little bit more in depth later on in the year, so we'll just get kind of a little taste of it today. So the first thing we want to talk about is brain hemisphere organization. And really the idea here is to understand that our brain is split into two hemispheres, the left hemisphere and the right hemisphere, and that each one is going to kind of specialize in specific tasks. Now, even though they are specializing, both sides of the brain are going to be constantly interacting and talking to one another. And it's really important to remember that when we do something, it's not just one part of our brain that's doing all of it. It's communicating and interacting and using our whole brain all the time, basically. So one piece that's really important, one part that we haven't talked about of the brain, is the corpus callosum. The corpus callosum is actually going to be the piece that connects those two hemispheres and then allows them to communicate across it. So all it's doing is just sending messages between the two hemispheres back and forth. We can see the corpus callosum here in the bottom right image. It's this yellow kind of area. You can see it between our two hemispheres there. So again, messages will shoot back and forth between that area. We can also see it right here in a little bit different diagram from the side, right? If we're splitting the brain like on the hemisphere, right? You can see it right there. So it's at the bottom. Again, information going back and forth between the two hemispheres through this corpus callosum here. Now, like I mentioned before, each of our hemispheres tends to specialize in certain tasks. And again, even though there's these specializations, there's a lot of communication going back and forth. And I'll kind of hopefully try and point that out with some examples as we go through this. So our left hemisphere is going to be in charge of speaking and language, mathematics, and understanding literal, concrete ideas. In addition, it's going to control the right side of our body. So remember, there's as our kind of nerves are leaving the brain, that spinal cord, right, and they're going out to the body, they're actually going to cross over, and so the right side of the brain is going to control the left side of the body, and the left side of the brain is going to control the right side of the body. Okay, so there's that swap there. So again, speaking and language, mathematics, and understanding literal, concrete ideas is the left hemisphere. The right hemisphere is going to fill some other tasks. So the right hemisphere is going to be involved in making inferences, recognizing faces, perceiving and expressing emotions, helping orchestrate self-awareness. In addition, obviously, it's going to control the left side of the body. Now, you should notice these kind of differences between the two sides. One is very much literal and concrete. Another one is more inferential, emotional in a way, I guess you could say, although there's obviously, the other parts of the brain we've talked about are going to be in charge of emotions, like the limbic system. But they're going to be working in concert all the time. So a nice way to think about this is like if you're going to read something. So let's say like right now you guys are reading the literal words on a page, right? As you're reading, that's all happening in the left hemisphere, right? It's the part that actually understands language. So it's picking up the words and it's understanding what those words mean. Now, one of the things that's important, though, is that it only is pulling the literal, concrete meaning of the words. So what is the dictionary definition, I guess you could say, for the words that you're seeing? Your right hemisphere is doing the inferencing. So when you think about you read something, right, a sentence doesn't necessarily mean exactly what you're saying, right? It doesn't word for word mean what you're saying, right? So like if I said like something went over your head, right, that doesn't literally mean like a physical object went over your head, right? Our left hemisphere is going to understand it that way, as a literal concrete thing that literally something went over your head. Our right hemisphere is going to make that inference. It's going to understand, right? It's going to read between the lines. It's going to understand that, okay, it's a figure of speech, right? It means something else. And so that's kind of where I say when I mean, even though they're each going to specialize in one thing or another, there is a lot of interacting and a lot of them kind of going back and forth and working on the same task. So when you're reading, even though the actual reading part and the language part and the literal concrete part is happening on the left side, that right side is also working on trying to understand the emotions in the text, is trying to understand any inferences or self-awareness of what's going on, right? The connections you're making to it. So there's a lot of interaction that's going on in the brain all the time, even when we have these two sides that have their specialties. That's going to get us to consciousness. So like I mentioned before, we're not going to do a ton about consciousness today. I really just want to hit on kind of a few main pieces. So one, what is consciousness? What does that mean? And then we're going to talk a little bit about dual processing as well. And again, these things will be things that we see again later on in the year, but we just kind of want to get a little bit of an idea of them now. So consciousness is our subjective awareness of ourselves and our environment. So for something to be conscious, we have to actively be aware of it. So, and this is really tricky. It's kind of a hard thing to wrap your mind around, because something that's unconscious or subconscious, we're not aware of it. So it's really hard to kind of imagine what the difference is. We will see, like, I think maybe even better examples of this when we talk about sensation perception. So one thing is to understand that, like, your ears are constantly listening, right? They don't stop listening or start listening. They're always picking up sounds, right? But when you are, like, maybe reading a book and you're focused on the story, you might not notice the sounds that are going on around you, right? A really simple example is sounds that are constant, like the sound of, like, a fan or traffic, right? As you get used to it, it kind of goes away. Now that sound is still hitting your eardrum, and your ear is still saying that it's there, but we're not consciously aware of it necessarily. Okay, so things that are conscious, we are actively aware of what is going on. Everything that's unconscious or subconscious are going to be things that are happening, but we aren't necessarily consciously aware of them. Another example could be like our heart beating, right? You don't actively think about your heart beating, it just does it on its own, right? Your brain is still telling your heart to beat. It has to do that, otherwise your heart just wouldn't do anything and you would die. So subconsciously, our mind is working that out, right? That unconscious part of our mind is literally going and telling our brain to beat, or our heart to beat, right? Every time it beats. So there's these two things that are happening. Now, our brain is doing conscious and unconscious tasks at the same time, right? And this is kind of one of those things that we'll talk about in a little bit as well, right? This idea that our brain is always doing something. So it's doing these both at the same time, and this process of doing both conscious and unconscious tasks at the same time is what is called dual processing. So we're processing two different ways, unconscious and conscious. So let's talk about these different types of processing. So we can break dual processing into two different types. The first one is parallel processing. Parallel processing is going to be our unconscious, very quick, reactionary thought, I guess you could say. Now, again, these are things that are unconscious, so we're not actively aware of them. And usually what's going to happen is our parallel processing is taking control or taking care of things that are considered routine. So again, like an example is our heart beating, right? We don't have to consciously do that. Our heart just does it. Our brain is just telling it to do that all the time. Same thing with certain tasks can become parallel, right? So something like walking. When you're a little kid, like when you're really, really young, like a baby, right? They have to put conscious effort into walking, right? And you can kind of see them, like when babies are learning how to walk, you can see them like consciously thinking about moving their legs certain ways to try and walk, right? And holding their balance. Where, once you get to, you're in elementary school or a teenager or an adult, right? When you go to walk somewhere, you just get up and walk. Right? You don't even really think about doing it. You don't think about your legs moving. You don't think about your balance. You just get up and start walking, right? That's this idea of parallel processing. Now, the other type of processing that we would, as a part of our dual processing, would be sequential processing. So sequential processing is the type of processing that we're going to use consciously, and it's going to be used to solve new problems. So anytime we have to come up with something, anytime we're confronted with something that's brand new, right? we have to use sequential processing. Now, again, one of the things that's important about it is it requires attention. We have to pay attention to it. So sequential processing has to be conscious, right? So when you go to class, right, let's say you go to class and you have a math class and you have a math problem, the math problem is going to require sequential processing, right? You have to actively think about the problem and try and solve it. Now, over time, some of that might become more like parallel. So it's a good example is like multiplication tables, right? When you're like younger, a lot of us have to like memorize multiplication tables, and you probably did those like time tests where you're trying to do all the multiplication tables or division tables as fast as you can, right? And after you've done it so many times, it can kind of move into that parallel processing piece, right? Where it doesn't necessarily take a ton of conscious effort. Once you've memorized, right, that like 5 times 5 is 25, you just know it every time. You don't have to actively think about it because it's not a new problem. So we can like move processes over into that more parallel area, okay? Another really nice example that I usually use is with like athletics or music. Actually, playing a musical instrument is a really good example as well. When you first learn to play a musical instrument or you first learn to play a sport, you have to consciously think about everything you do, right? If you're learning how to play guitar, you have to consciously think about every single finger and where it goes. Now, after you've done it a million times, you just play, right? And you don't have to think about where your fingers are. You don't have to think about where you're strumming. You just kind of go, and you don't really think about it at all, right? We see the same thing in athletics, right? This idea that like once I've done a certain movement a million times, right? The first time I did it, I had to actively think about every part of my body, where it goes, where it's not supposed to be, what do I do? But once I've, played this sport for 10 years, now I can do it at full speed without even thinking about it. I just react. Okay, so again, we've taken things that were sequential at the beginning and we've moved them into that parallel processing, things that are just taken care of unconsciously even. Now, we can actually kind of see this a little bit in how our brain, like how active our brain is. And so what we know is the difference basically between being intensely focused on a task, right? So like focusing as much as we possibly can, trying to figure something out. And when we're just like sitting around normal is only 5%. So our brain is always doing things. It's always taking care of problems. It's always solving things. It's always making sure our body is functioning. It's always sending and receiving information. It never just sits there and does nothing, really. It's always processing. It's always working. That's going to get us to neuroplasticity. So neuroplasticity is basically the way that our brain changes over time. The idea of neuroplasticity is that our brain creates new neural pathways. So this can happen for a whole lot of reasons. Basically, the main way that we're going to see neuroplasticity is as our brain does something, every time we do a certain behavior, which is obviously neurons firing at the most basic level. So as those neurons fire, the more often they fire together, the more likely they are to connect, which is wired together, right? Neurons that fire together, wire together. The more likely they are to connect, the more connections they're going to make, and the easier it is to use that pathway later on. So the easier it is to use that pathway, the more likely we are to do that behavior. So neuroplasticity is really important when it comes to behaviors. It's really important when we talk later on about like clinical psychology as a way to try and deal with different kinds of psychological issues. Sometimes it can be just if I force you to do this behavior over and over and over and over again, you'll stop doing this other behavior that's more negative. We also see neuroplasticity through neurogenesis. Neurogenesis is just the creation or the production of new neurons. So over time, neurons do die, so we have to create new ones to fill those space and to mend, those different parts. And that's what neurogenesis is. It's pretty straightforward there. All right, so that is going to wrap up this little kind of section, and this is really wrapping up the brain. As we move forward, we're going to look at the peripheral nervous system and the endocrine system, which are not really super connected to the nervous system at all, to the brain, the central nervous system. So this is kind of that wrap up of our brain, and then we're going to start looking at other parts of our nervous system and then our endocrine system, which is entirely separate. So please make sure you go through, do a quick summary to wrap up what we talked about today.